In this video we will see an interesting application on the calculation of the volume of a sphere, but in this time the sphere will have a time-dependent radius. So the radius of the sphere should be a function of time. We know that the volume of the sphere is 4/3, is given by this formula. Now the volume is a function of time and the radius of the sphere is a function of time. And we will pick the radius to be 10 times e to the minus t. This is a time-dependent radius. This is a time-dependent radius, so if the radius is time-dependent, also the volume of the sphere is time-dependent. So instead I write that v of t equals this quantity here times r to the power of 3 of t, where r of t is this function. Now let's find the derivative of the function with respect to t. I am calculating the derivative of the function with respect to t. So these are not the functions of t, these are just constants, they can go out of the derivative. And I will have the derivative with respect to time of the radius cubed. So this is 3r square of t times r prime of t, where r prime is the Lagrange notation and is the derivative dr dt. This is Lagrange and this is Leibniz. Now let's substitute, let's do some cancellations. The threes can be simplified. The radius is 10 times e to the minus t squared, and then we have the derivative of the function is 10 e to the minus t times minus 1, so it should be 4 times pi times 100 e to the minus 2t times 10 e to the minus t, and of course we have a minus here, so it is minus 4000 times pi e to the minus 3t, and is strictly negative. V prime is strictly negative, so the function v is a monotonically decreasing function for every t belonging to the 0 infinity. Now let's see the next step. So this is a monotonically decreasing function, so it means that if you increase the radius, when time goes by, the ball shrinks. The ball shrinks, and also we can say that the limit of v of t as t grows to infinity is the limit as t grows to infinity 4/3 times pi times r to the power of 3. So it's the limit as t grows to infinity 4/3 times pi. This is 10 to the power of 3 e to the minus 3t. So it is the limit as t grows to infinity of this quantity, and this goes to 0. So as t grows, the volume of the sphere becomes smaller and smaller and tends to 0. So what this should be visually, so you start with initial time t0, so this is the radius r0, rt0 for t equal to 0, then the radius becomes r1, it is becoming smaller, r1 equals rt1, Then the radius becomes even smaller, r2 is rt2, and of course t0 is less than t1, less than t2, less than t infinity. So you have a shrinking ball as t goes to infinity, as t increases.